So next is the coefficient of variation. Coefficient of variation. So standard deviation of a variable measures the variability, which can also be called as dispersion of the variable. But if we want to compare the dispersion of two variables with different units or even means, then standard deviation does not work because it will be different. So you have to use a coefficient of variation as a means of relative, and it is really just what it is. It is the standard deviation divided by the mean. So that is the coefficient of variation. It can sometimes be expressed as a percentage also, then it becomes percentage coefficient of variation. And if the mean can be negative, then we just do take its absolute mean. So then it becomes s upon absolute y times 100, where y, this is the absolute value of y. So that's basically what it is, the coefficient of variation. The next thing is that what is the coefficient of variation of an estimator. So for an estimator, standard error of the estimator measures its variability, right? Variation between different values of estimators from different samples, and that's the difference. So values or variation between different values of estimators from different samples, that is the standard error of the estimator. So standard error can indicate the precision of the estimator, but if we want to compare two estimators, we can use their coefficient of variation instead of the standard error. So coefficient of variation is just the value of standard deviation divided by the mean, and it is a unit free indicator of the relative precision of the estimator, and it shows the variability relative to the mean. Estimator of the coefficient of variation can be obtained from sample observation by taking the ratio of the sample standard deviation. So coefficient of variation of the y bar will be just small s of y bar divided by the y bar. In sample surveys, often the estimate together with its coefficient of variation are reported to assess the relative precision of the estimate around the sample. So this is the coefficient of variation, which is just a small s of the y bar, which is the um, you know it is of the y bar, it's not of yi, and divided by y bar will give you the coefficient of variation of the estimator. So an example of that is that we have two surveys, survey 1 and survey 2, of the population mean y1 bar and y2 bar were to be estimated. Two sample surveys were calculated and their sample means were, so their yi bar, the y1 bar of that sample was 34972, and the standard deviation of S y1 bar is 1321. Now this is the standard deviation of y1 bar, which will be calculated by the formulas for standard deviation depending on SRSW OR or not. The variation is calculated by this formula. So S square, and you can put it a small s square there also, but that's the sample variance and not the anyways, we got that, and we got y2 bar and then sy2 bar, and then we can calculate, and then we can differentiate from them that for example this one comes out to be 456 and its standard deviation is 234, and you can look at this and say, oh, this looks more precise, but that doesn't really help, because what you need is coefficient of variation, which is the standard deviation divided by the mean. So if you do this, you will find out that this is actually more precise. So relative precision of y1 is much more.